The invention of the integrated circuit is a pivotal moment in human history, marking the dawn of the modern electronics era. Before this breakthrough, the world of electronics was a cumbersome and inefficient realm dominated by bulky vacuum tubes. These glass tubes, though revolutionary in their own right, were prone to failure, consumed enormous amounts of power, and generated significant heat. The invention of the creating the sophisticated electronics that engineers dreamed of. In the summer of 1958, a quiet engineer named Jack Kilby at Texas Instruments found a solution. While the factory was on a company-wide vacation, this was the birth of the monolithic idea. On September 12, 1958, Kilby successfully demonstrated the first working integrated circuit. It was a simple device, a single transistor with a few other components on a small piece of germanium. It was not elegant, but it was proof of concept that would change the world. Simultaneously, Robert Noyce at Fairchild Semiconductor was independently working on a similar concept. Noyce's design, using a planar process on a silicon wafer, was more practical for mass production. This parallel innovation highlights a common theme in science. Circuits. This adoption by the Apollo program provided a massive boost to the fledgling IC industry. It drove down production costs and proved the technology's reliability under the most extreme conditions. By the late 1960s, ITs began appearing in commercial products like pocket calculators. This was the first time the power of miniaturization was placed directly into the hands of consumers. In 1965, Gordon Moore, a co-founder of Fairchild and later Intel, made a famous observation. He predicted that the number of transistors on an integrated circuit would double approximately every 2 years. This prediction, which became known as Moore's Law, has served as a self-fulfilling prophecy for the semiconductor industry. The relentless pace of Moore's Law led to the next great leap, the microprocessor. In 1971, Intel introduced the 4004, the world's first commercially available microprocessor. This single chip contained all the elements of a central processing unit, a computer on a chip. The microprocessor democratized computing power, paving the way for the personal computer revolution. Hobbyist kits like the Altair 888, powered by a microprocessor, sparked the imagination of early tech enthusiasts. This led to the founding of companies like Microsoft, which initially wrote software for the Altair. Then came Apple, with Steve Wozniak and Steve Jobs assembling their first computers in a garage. The Apple II, released in 1977, brought the personal computer into homes and schools. The IBM PC in 1981 solidified the personal computer as a mainstream business tool. None of this would have been possible without the dense, affordable computing power provided by integrated circuits. As computers became more powerful and widespread, the need to connect them grew. Integrated circuits were essential for building the infrastructure of the internet. Routers, switches, and modems. The explosion of the World Wide Web in the 1990s was fueled by the ever-increasing power of microchips. The new millennium saw the focus of innovation shift from the desktop to the palm of your hand. The development of the system on a chip, say SOC, was a key enabler of the mobile revolution. An SOC integrates nearly all components of a computer or other electronic system into a single chip. This incredible density is what allows for powerful smartphones, tablets, and wearable devices. Today, integrated circuits are the invisible bedrock of modern civilization. They are in our cars, our kitchen appliances, our medical devices, and our entertainment systems. The Internet of Things, IoT, promises to embed trillions more chips into the objects around us. build a better future.